Good morning, students. We'll start with the today's lecture. In the previous class, we have completed the board plot, right? And a variety of problems we have solved on board plot and how to judge the stability of the given system using the board plot that we have seen. Next, in this chapter, in unit 3, okay, once again, I have left one of the chapter in unit 3. Next, we'll switch back to unit 3, that is stability in frequency domain. Right? In the previous chapter, we have studied board plot. In this chapter, we will be studying the Nyquist plot. Nyquist plot. And in order to analyze the stability of the system, there are in time domain, we can analyze the stability of the system in time domain as well as frequency domain. In time domain, there were two methods we have seen. What is that? One is Ruth criteria and another one was root locus technique, right? Ruth criteria was the mathematical method, whereas your root locus technique was the graphical method, right? Then in frequency domain method, in the previous chapter, we have seen how to judge the stability of the system in frequency domain using the board plot. Here in this chapter, how to judge the stability of the system using Nyquist plot. What is Nyquist plot and how to judge the stability of the given system in frequency domain using Nyquist plot, that we will be studying. Okay, the syllabus here, mathematical preliminaries, some, right? We will be studying that. Nyquist stability criterion and assessment of relative stability using Nyquist criterion and numerical examples. Today I will not take up any of these topics because in order to study the Nyquist plot, there is something called as polar plot. So I should know what is polar plot, right? So first we'll study this polar plot, which is the basis or basics for Nyquist plot. If I understand polar plot, then only I will understand the Nyquist plot. So we will take up a brief introduction to polar plot and what is polar plot, right? All those things we'll study with respect to this polar plot, right? Okay, here in today's lecture, we'll see the brief introduction, then the polar plot, the numericals on the polar plot, and determination of gain crossover frequency, omega GC, phase crossover frequency, omega PC, gain margin, phase margin from the polar plot. If I study all these specifications, omega GC, omega PC, GM and PM for polar plot, it is as good as I'm studying for Nyquist plot. That we'll see it, right? One and the same. What is the slight difference between polar plot and Nyquist plot? We'll see. First, we'll study the polar plot. We'll concentrate only on this today, right? Okay. What we are going to study, brief introduction, what we are going to study in this chapter. So, Nyquist plot we are going to study, it is another frequency response method in order to judge the stability of the given system, right? So, we analyze the stability analysis using Nyquist plot. In this chapter, we'll do that. Then we'll study the polar plot, which is the basis for Nyquist plot. Then what is frequency response? Already we have defined the magnitude and phase variations, right? The magnitude and phase variations with respect to the input signal frequency that we have done in the previous chapter, that is board plot, right? The board plot consists of two plots, magnitude plot and phase plot. Magnitude plot is also called as gain plot, right? One and the same. Okay, next we'll see what is polar plot. Yes, here also magnitude is required, right? So here the magnitude, so we have the open loop transfer function g of s into h of s. So we will convert it into frequency domain, replace s by j omega. This is the open loop transfer function g of j omega and h of j omega. Right, we will calculate the magnitude and the phase phi. So here in polar plot, we take the magnitude versus the phase with respect to different frequencies, with respect to omega. Omega running from 0 to infinity, right? So what is polar plot means? The magnitude versus the phase, right? The magnitude versus phase of the open loop transfer function g of j omega and h of j omega with respect to frequencies varying from 0 to infinity. That we call it as polar plot, right? The same thing I told here. The polar plot, the magnitude of g of j omega and h of j omega is plotted against the phase angles of g of j omega and h of j omega for various values of omega. We know that magnitude is, we can write it, magnitude of g of j omega and h of j omega. 1 minute, CR is calling. Hello Tejas, tell me Tejas. I left the meeting. Okay, maybe problem with the internet connection, I think. Okay, let me check it. Okay. Okay. Thank you for it. 1 minute. I think there is problem with the net, I think. Yes, fine. Okay. Uh, Whether I have told what is polar plot, I was telling, right?
Yes, sir.
Sir, please present your screen, sir.
Okay, sorry. 1 minute, 1 minute. Yes, sorry. I thought already I have presented. Now my screen is visible to you. Yes, please
Yes, sir.
respond. Okay, fine.
Yes, sir.
Uh, I was discussing what is polar plot, right? Okay, I'll continue here. So before studying the Nyquist plot, we will study the polar plot because this forms the basis for studying the Nyquist plot, right? So what is polar plot? We have the open loop transfer function g of s into h of s. We replace s by j omega so that it will be converted to frequency domain, right? So the magnitude values versus the phase values. As I vary the frequency omega from 0 to infinity, that itself is the polar plot. That has been given here, right? So we know how to calculate the magnitude. So magnitude of j omega into h of j omega, and how to calculate the phase, that is angle of j omega into h of j omega. You know how to calculate magnitude and phase, right? The same thing we have to do here. We'll calculate the magnitude and phase. Okay, just for various values of frequencies. So we'll take the frequency omega. So let me take 0, omega 1, omega 2, and so on till infinity, right? These are the various values of frequencies. Then we'll calculate the magnitude and phase here. But here in polar plot, the magnitude, it is not mandatory that it should be in decibels. No need to convert magnitude, let it be. Whatever the magnitude we get, we will keep it as it is. So no need to convert it in decibels. It is not mandatory to convert it in decibels. Then phase, and one more thing. Omega, the frequency, no need to take the log of omega. Right? So log of omega, the frequency values, the logarithmic values of frequencies are not required. The magnitude m in decibels is also not required, right? So magnitude need not be in decibels. Then frequency, logarithmic values of frequency also is not required, right? This please keep in the mind. Okay, we will vary the omega. Then we'll calculate for omega equal to 0 frequency at 0 hertz. We'll calculate the magnitude and phase. So let me assume that for omega equal to 0, magnitude is m naught and phase is phi naught. General we are telling. For omega equal to omega 1, magnitude is m1, phase is phi 1. Similarly for omega 2, magnitude is m2, phase is phi 2. Similarly for omega frequency infinity, magnitude is m of infinity and phase is phi of infinity. And please, once again, I'm stressing, we will not take the logarithmic values of a frequency, and magnitude may not be in decibels, right? Please keep in the mind. Then we'll see the polar plot here. This is the polar plot. So you know this is the real axis, right? Sigma, and this is the imaginary axis j omega, right? Okay. For omega equal to 0, what is the magnitude? It is m naught. And what is the phase? Phi naught. So it is some angle. So let me draw for first value of omega equal to 0. So draw one line at an angle of phi naught. This is phi naught. Draw one line. So look, this line, how much, what should be the length of this line based on the magnitude? Suppose if it is 1, so it should be 1 unit. Mark one point here. So this is for omega equal to 0. For omega equal to 0, the magnitude from this origin, from origin to this point P naught is magnitude, that is m naught, and angle is phi naught. Then next, for frequency omega equal to omega 1, the magnitude is phi 1. Measure the angle phi 1 here, right? And magnitude, let me take m1. So from here to here, the magnitude, mark this point for omega equal to omega 1, and so on. You just go on, continue. You will take the last frequency for omega equal to infinity. Angle is phi of infinity, so this is phi of infinity, and magnitude we measure it, that is m of infinity, and mark this point. So just go on joining all these points, right? This itself is the magnitude plot, right? Sorry, polar plot. So the magnitude versus frequency, phase, magnitude versus phase, as omega is varied from 0 to infinity. This is nothing but our polar plot. So let us call this p naught, p1, p2, and p infinity. These are tip of phasors. This is a phasor. From here to here we call this as a phasor. This is the angle and this is the magnitude. So by joining all the tip of phasors, we will get the polar plot. We call this as phasor lengths from here to here. P naught, this is one phasor length. 0 to P1 is another phasor length. So joining the tip of the phasors, we will get the polar plot. I hope you are getting. If any doubts, please unmute yourself and get your doubts clarified at the same moment. Don't wait, right? Okay, next we'll take up one of the example. Consider a system with the open loop transfer function g of s into h of s is equal to 10 by s. So obtain its polar plot they are telling, right? So, okay, fine. We'll solve it. Okay, first we'll try to obtain replace s by j omega, right, in the open loop transfer function. So g of j omega into h of j omega equal to 10 by s is nothing but j omega. So express in complex form 10 plus j0, 0 plus j omega. I can write this, then get the magnitude m, then get the angle, phase phi. So we know you know how to calculate magnitude. If you are having any doubts how to calculate magnitude and phase, or you ask me, I will tell once again, no problem, right? So magnitude m is equal to magnitude of j of j omega and h of j omega. M is equal to, so how to calculate magnitude? Numerator under root of 10 square plus 0 square. So I am getting 10. Then denominator under root of 0 square plus omega square. I am getting omega, right? This is the magnitude 10 by omega. Then calculate the phase phi, angle of j of j omega and h of j omega. Phi is equal to, so angle of 10 plus j0. So it is 0 degree. So it is 0 degree. Angle of 10 plus j0, it is 0 degree. Then in the denominator 0 plus j omega, it is located on imaginary axis, so it is 90 degree. So take it to numerator, it is minus 90 degree. I hope you are getting. This is the magnitude and this is the phase. Okay. Then we will make the table. Table consists of frequency omega is varied here, and this is the magnitude and this is the phase. We have the magnitude equation, m is equal to 10 by omega. So let me write it here, m is equal to 10 by omega, we got it. And phase, it is constant, minus 90 degree. It is not depending on the frequencies. You can observe here. Let me take the values of frequency 0, 10, 100 till infinity. You can observe the phase column. This is minus 90 degree. It is independent of the frequency. For all the values of frequency, the phase angle contributed is minus 90 degree. So we will list out here. Next, we will calculate the magnitude. So for omega equal to 0, what is the magnitude? So 10 by 0, anything divided by 0 is infinity. So this is fine, over. Next, substitute omega equal to 10. 10 by 10, it is 1. So magnitude is 1. Next, substitute 10 by 100. So it is 0.1. Frequency omega is infinity. Anything divided by infinity is 0. So this is 0. I hope you are getting. So we have made this table. So we have several magnitude values and phase values for different frequencies. Omega varied from 0 to infinity. Next, we have to draw the polar plot. Let me show you the polar plot here. Observe here. So this is sigma, the real axis, and j omega, the imaginary axis. Then if I measure the angle in anti-clockwise direction, it is positive, 0 degree, 90 degree, 180, 270, 360. But for polar plot, we usually take the negative angles. Means this is 0 degree, this is minus 90, then this is minus 180, then this is minus 270 degree. Right? So we measure the angles in the clockwise direction. The angles that are measured in clockwise direction are negative. So 0 degree, minus 90 degree, minus 180, minus 270. Right? So now you are ready. Next, first we'll take for omega equal to 0. What is the magnitude? It is infinity. Right? So what is the phase? Minus 90 degree. Minus 90 degree means this line, right? This one. But what is the magnitude? Infinity. I cannot just go on till extending this negative. So let me mark infinity here. This is my infinity. Actually, this is not infinity, but let me take this is infinity, right? So what is this? So at omega equal to 0, right? So what is the angle? Minus 90 degree. What is the magnitude? Infinity, right? We have marked here. Next, for omega equal to 10. So what is magnitude? It is 1. What is angle? Minus 90 means once again the same line. So magnitude is 1. Let me take 1 here. Actually, this is infinity, right? So here infinity, this is infinity, and this is 1. Magnitude, I am writing. No need to write magnitude, right? So this magnitude is 1. Next, for omega equal to 100, on minus 90 degree line, magnitude is 0.1. This is 1 means 0.1 will come somewhere here. Mark it. I hope you are getting, right? So we have marked several points. So join all these things starting from here, omega equal to 0. Then at omega equal to infinity, what is magnitude? It is 0. The point will come here. I hope you are getting. Then this is the polar plot. Let me change the ink color. So, and here omega equal to infinity, where magnitude is 0 but angle is minus 90 degree. So it starts from omega equal to 0 till omega equal to infinity. So let me write it right. So this is the direction. So frequency omega is varied from 0 to infinity. So magnitude values are changing, but this phase minus 90 degree, it remains the same. This is the polar plot. Okay, this is fine. Is it correct? Okay, I understood. The same thing has been shown here, right? For omega, the same thing. I have drawn here this one and the same, right? Okay. If any doubts, you ask, or else I will proceed with the next numerical. This is the polar plot for g of s into h of s is equal to 10 by s. This is the polar plot, right? Next, we'll go to the next numerical. Consider a type 0 system with open loop transfer function g of s into h of s is equal to 1 divided by 1 plus ts, where t is constant. Obtain its polar plot. Type 0 system means none of the poles are lying at origin, right? You know this. None of the poles are lying at the origin. So that is type 0 system. 1 divided by 1 plus ts. This is already in standard time constant form. 1 plus ts, right? Okay. So next, as usual, we will obtain the magnitude of this. So solution, the magnitude of this and frequency, right? So replace s by j omega, right? So 1 plus ts, s is j omega, and express in complex form. I can write 1 as 1 plus j0, 1 plus t, j omega into t, they have written, right? Then obtain the magnitude m. So magnitude m is equal to magnitude of j omega into h of j omega. So under root of, so if numerator, under root of 1 square plus 0 square is 1. In the denominator, under root of 1 square plus omega square t square. This is the magnitude. The next, we will calculate the phase phi. So angle of g of j omega into h of j omega. Numerator. So numerator here. The angle of 1 plus j0, it is 0 degree. We know this. So tan inverse of imaginary part by real part. Tan inverse of omega t divided by 1. So tan inverse of omega t, denominator. Take it to numerator, it is minus tan inverse of omega. So phi is minus tan inverse of omega t. We are ready with magnitude and phase. Next, we will vary the frequency. We will make the table. Yes, for omega equal to 0. What is magnitude and what is phase? We will calculate. For omega equal to 0, what is the magnitude? Substitute 0 here. So this is 0 means 1 plus 0. Root of 1 is 1. 1 by 1. So I am getting magnitude as 1 for omega equal to 0. Then we will calculate the phase. So substitute omega equal to 0. Tan inverse of 0 is 0. So I am getting 0 degree. Is it fine? Next. Yes, you can observe here there is omega square t square. So don't take just omega equal to 1 or 10, because you take in the form of 1 by t, 10 times 1 by t, 20 times 1 by t, 100 times 1 by t, and so on till infinity, right? Don't take just omega equal to 0, 1, 10, 100 like that. In terms of time constant you take it, so that this t gets cancelled and I'll get the magnitude value and phase value. Okay, let me take the next value, omega equal to 1 by t. So let us calculate the magnitude. Substitute here, what is omega? 1 by t, 1 by t square. T square will get cancelled. This will be 1, 1 plus 1, root 2, 1 by root 2, 1 by root 2. Is it fine? So let me calculate this value. What is 1 by root 2? So 1 divided by root 2. So I am getting 0.707. Let me write it here, 0.707. Then we'll calculate the phase, minus tan inverse of, what is omega? 1 by t. So tan inverse of 1 is minus 45. Tan inverse of 1 is 45, but minus sign is, so minus 45 degree. Is it fine? Then next, for value of omega equal to 10 by t. So substitute 10 by t here, right? 10 by t here. 10 square means 100, right? And by t square. T square, so 100 plus 1. 1 by root of 101. What is 1 by root of 101? We will calculate 1 divided by root of 101. So it is 0.09. 0.099. Okay, we will calculate the angle. Substitute omega equal to 10 by t here. So tan inverse of 10 you calculate. So minus sign, 84.2 degree I will get. Similarly for infinity, right? Calculate the magnitude for infinity. Substitute infinity here. So anything divided by infinity is 0. So that is magnitude, right? Then calculate the angle. Substitute infinity here. Tan inverse of infinity is 90 degree, but minus sign is there. So minus 90 degree. So this table is ready. Next, we will draw the polar plot. Is it fine? Okay. So sigma real axis, j omega the imaginary axis. So I'll start here 0 degree, minus 90 degree, 1 minute, okay, minus 90 degree, minus 180, minus 270. So we'll see the polar plot, how we'll get. Okay, for omega equal to 0, phase is 0 degree. 0 degree means this line. So what is the magnitude? It is 1. So let me mark magnitude here, it is 1. For omega equal to 0, phase phi is 0, 0 degree, this line, and magnitude is from here to here, it is 1. From here, let me mark from 0, right? From here to here, it is magnitude is 1. You can write, if you want to write magnitude 1, you can write, or else, right? You can draw as per the scale. You can use the normal graph sheet and you can draw this, or else roughly we will draw. No problem, right? Then for next value of omega equal to 1 by t, so the so angle is minus 45. So let me draw minus 45 here. This is minus 45. So what is the magnitude? 0.707. From here to here the distance is 1. 0.707 means, let me mark one point here. This is for omega is equal to 1 by t. For omega equal to 0, it is over. For omega equal to 1 by t, I have marked this point and over, right? Next, for omega equal to 10 by t, so minus 84.2. Let me draw the line, minus 84.2. From you measure the angle from here. So this is, let me take minus 84.2, somewhere it is coming here, right? This is the angle, minus 84.2. You have to make use of protractor, make this as origin and mark minus 84, right? And what is the magnitude? 0.09. Let me 0.1. Let me round it. 0.1, right? So 0.1 means the point will come here somewhere. Is it fine? Then this is also over. Next, at omega equal to infinity, what is the angle? Minus 90 degree means this line. Minus 90 degree is this line. What is the magnitude? 0. The point will come here. This is for value of omega equal to infinity. So let me join all those points. So I'll change the ink from omega equal to 0. It goes like this. I hope you are getting. So this is the polar plot. Omega equal to 0 is the starting frequency. Omega equal to infinity is the terminating frequency. Starting frequency omega is 0 and terminating frequency omega equal to infinity. Right? So as I move from omega equal to 0, the frequency goes on increasing and it reaches infinity. And there are several magnitude values and corresponding phase values. Right? So this is the polar plot. So please try to remember g of s into h of s is equal to 1 divided by 1 plus ts. The polar plot is of this shape and it is lying in, let me mark these quadrants. That will be helpful for me later on to have, this is first quadrant, second quadrant, third quadrant, fourth quadrant. So if the transfer function g of s into h of s is 1 divided by 1 plus ts, this is simple pole, right? So I will get the plot in fourth quadrant, right? This is the shape. Please try to remember. Why, I will tell you later, right? Okay, in the next slide, the same polar plot has been given here. The same thing here. They have marked here, right? This is the polar plot from here to here, whatever I have drawn here, right? So I will not explain because already I have drawn here. Next, we'll take up this example. But here in this example, okay, fine. We'll take up this. In previous example, we have considered type 0 system, leave it. Now we will consider the type 1 system with the transfer function g of s into h of s is equal to 1 divided by s into 1 plus ts, obtain its polar plot. So earlier there was this s was missing there, that was type 0. Now we have included the pole at origin. So this is type 1 system, right? Okay, as usual. So replace s by j omega. Yes, we will do it. 1 by j omega, 1 plus t into j omega. Write in complex form 1 plus j0. This 0 plus j omega, this one as it is. Fine. So this is in frequency domain. Next, calculate the magnitude m. So magnitude m is equal to magnitude of g of j omega into h of j omega. Numerator under root of 1 square plus 0 square is 1. Under root of 0 square plus omega square is omega. From this term, under root of 1 square plus omega square t square. Is it fine? This is the magnitude m. So calculation of magnitude and phase is same for all the problems of polar plot. First we'll calculate magnitude and phase. First replace s by j omega and write down the open loop transfer function. Then get the magnitude, then the phase. Phase angle phi is equal to angle of g of j omega and h of j omega. angle of 1 plus numerator, right? Angle of this 1 plus j0, it is 0 degree. Then angle of 0 plus j omega, it is 90 degree. Angle of this tan inverse of imaginary by real part. So tan inverse of omega t by 1. So this is fine. So take it to numerator. The phase angle phi is minus 90 degree minus tan inverse of omega t. So this is the phase. So we obtained the magnitude and phase both. The next, what we have done, we used to construct the table. But here in this problem, we will not go for table. Here we have taken this table, right? So what we will do, we will consider, we will not take the entire all the values of frequency. I will consider the starting point, let me call it as sp, starting point omega equals 0, and terminating point tp, omega is infinite. I will consider the starting point and terminating point, that's all. And I will calculate the corresponding magnitude and phase values for starting point and terminating points. I will not consider the in between values, these are discarded, right? In this next numerical, this is another way of solving the problem that we will see. So we are ready with magnitude and phase. So let me take the starting frequency. Let me call it a starting point where omega is equal to 0. Let me write it equal to, no need to show this. Write down directly as omega equal to 0. Right? Next, terminating point or ending point. So where omega is equal to infinity, you will calculate only for these two frequencies. Intermediate 0 to infinity will not consider, right? For omega equal to 0, what is the magnitude? So we write like this here. Magnitude at an angle of phi. So first we'll calculate what is the magnitude and angle, right? So omega equal to 0. So substitute 0 here. Anything, so 0. Anything divided by 0 is infinity. So magnitude is infinity. Next, we will calculate the angle for omega equal to 0. Minus 90 degree minus tan inverse of 0 is 0. So minus 90 degree. So I will be getting angle of minus 90 degree. So let me write it here. Infinity is the magnitude and phi. So we will write it like this. This is magnitude angle of phi. So magnitude is infinity, angle is minus 90 degree for omega equal to 0. I hope you are getting this, right? Okay, next, for omega equal to infinity, calculate the magnitude. Anything divided by infinity is 0. So the magnitude is 0. Next, we will calculate this angle, how it is minus 180. So substitute omega equal to infinity here in phase equation. Minus 90 minus tan inverse of infinity. This is 90 degree. Minus 90 minus 90, it is minus 180. Is it fine? So we have obtained magnitude and phase for omega equal to infinity. We have taken only the starting frequency and ending frequency. We call it a starting point and terminating point. Okay, once we have the starting point and terminating point, so here you can observe here in the previous problem, this is the starting point omega equal to 0 and terminating point is omega equal to infinity. This is the starting point and this is the terminating point, and the plot has rotated in the clockwise direction by 90 degree. So we have to find out the rotation of plot. How to find out that rotation of plot, we'll see. You can observe here how to find out rotation of plot. So always you subtract the phase angle from terminating point to starting point. So terminating point, it is minus 180 degree, starting point is minus. So always you subtract like this. Always. So minus 180 minus, so it is written here, rotation of plot. Rotation of plot is equal to minus 180 degree is the phase angle contributed by the terminating point minus of minus 90. So minus of minus 90. So I am getting minus 90 degree. So if the angle is negative, so we always angle, if I measure the angle in clockwise direction, the angle is negative. If I measure the angle in anti-clockwise direction, the angle is positive. But I am getting minus 90 degree. Means what I should write? The plot should, how the plot should rotate? The plot should rotate by 90 degree in clockwise direction, because angle is negative now. If angle is negative, the plot will rotate in clockwise direction. By what angle? 90 degree here. So I will write minus 90. Minus 90 is nothing but 90 degree clockwise rotation of the plot. Starting point to terminating point. So we will see this. This is this information we have in this table. This is the table we have constructed. Next, using this information, we will try to draw the polar plot. Let me draw it here, because if I go to next slide, I have the solution. So I will not go here, only I will do it. Is it fine? Okay. Let me change the ink color. Let me draw it here only. Sigma j omega. This is 0. So 0 degree minus 90 degree, minus 180 degree, then minus 270 degree. Next, we will make use of this data. At omega equal to 0, what is the angle? Minus 90 degree. Minus 90 degree means this line. What is the magnitude? It is infinity. Infinity means I have to take somewhere. Let me take this infinity. This has infinity. Actually, this is not infinity, but I will assume this is infinity. We have reached infinity. So, what is the starting point? It is omega equal to 0. Magnitude is infinity, but angle is minus 90 degree. This is fine. We have marked here. Next, terminating point. So angle is minus 180. Minus 180 means this one, this line, right? This is minus 180. What is the magnitude? 0. So magnitude is 0 means here. So angle is minus 180 degree. Magnitude is 0, right? So where omega equal to infinity. So we have seen this is the starting point and this is the terminating point. I have starting point and terminating point, and I will come to this rotation of plot information. So it is telling rotate from starting point to terminating point 90 degree clockwise direction. So this is 90 degree. So I will rotate like this. So this is rotation of the plot. This is 90 degree clockwise rotation. 90 degree clockwise. So this is the polar plot. I hope you are getting any doubts. Yes, the same thing has been shown in the next slide. This thing, right? The same thing, right? I have drawn here the same thing. This is the polar plot. And observe here, one more thing you should observe. There should be some observation. Okay, we will make that observation later. Okay, this I hope you understood how to get the polar plot of this. Okay, next we'll move to the next. Yes, consider a type 2 system. Next we'll move to the next numerical. Consider the type 2 system with open loop transfer function g of s into h of s is equal to 1 by s square into 1 plus ts obtained. This is type 2 system. This is type 2 system because there are two poles, s square, two poles lying at the origin, right? Type 2 system. And you take this as a homework, you do it as usual, right? So first get the magnitude, get the phase, right? You will get some equation for magnitude. Replace s by j omega. First get j of j omega into h of j omega. Just I'm giving the hint how to solve it. Then get the magnitude, then get the phase, then starting point of frequency and terminating point. So omega equal to 0, omega equal to infinity. So what is the magnitude and phase you calculate? What is the magnitude and phase for this? Then get rotation of plot. This let me call this phi 1, this is phi 2. So here rotation of plot is phi 2 minus phi 1. You get something, right? If it is negative, it is clockwise rotation. If it is positive, anti-clockwise rotation, right? So you draw it, you will get the polar plot. This is the polar plot, you will get it. This is how you will get it. So starting point, right? Starting point omega equals 0 and ending point 90 degree clockwise rotation. So you take it as homework and you do it, right? And observing this, yes, we have done so many numericals with respect to simple pole. So earlier there was no s square, just 1 by 1 plus ts. I got polar plot. Then there was only one pole at origin, s power 1, s square, s cube, and so on. I have to make some observations. What are those observations? Next I have concluded. And this is the key point I have written here. Just concentrate on this. So finally, observing all these things, it can be concluded that a pole at origin shifts the starting point of the polar plot by 90 degree in clockwise direction, keeping the rotation of the plot same. Rotation of the plot means starting point to terminating point. Rotation of plot is 90 degree everywhere. For this also it is 90 degree. For this also it is 90 degree. If I take this 90 degree, right? So we will summarize in the next slide. You can observe here. We have solved for g of s into h of s is equal to 1 divided by 1 plus ts. This is the plot. The rotation is 90 degree clockwise, right? This we have seen 90 degree clockwise. Next, if for this, if I add one of the 0 at origin, means 1 by s into 1 plus ts. If I add 1 0, what will happen? This starting point shifts by 90 degree here and the plot will come here like this. That has been shown here. You can see here. Right? Starting point shifts here. Starting point shifts because one pole is added. So one pole is added means the plot will shift by 90 degree, the starting point. So from here, the starting point will shift to here, 90 degree. in clockwise direction. Please keep in the mind. The same thing has been written here. It can be concluded that a pole at origin, if there is a pole at origin, it shifts the starting point of the polar plot by 90 degree in clockwise direction. This is very important. 90 degree in clockwise direction, keeping the rotation of the plot same. So for this simple pole, we are adding one of the pole at origin. So the starting point shifts by 90 degree here, and rotation of the plot remains the same like this, right? I am not just, it is shown here, right? It shifts here, and this is the plot. I hope you are getting. Next, if there are two poles at origin, means s square, for example, s square, 1 by s square into 1 plus ts. So two poles are there, right? So if I add two poles for this, so earlier there, right? So 90 into 2, 180 degree clockwise rotation. So from here to here, it is 90 and 180. Starting point will come here, 180. So, and this is ending point. So it will join like this. So plot is coming like this. So, I hope you are getting two poles. Can anyone draw and show me how the, just I will, g of s into h of s is equal to 1 divided by s cube into 1 plus ts. What is the plot I am getting? Can anyone tell? Whether the plot will come in which quadrant, can you tell? So this is first quadrant, second quadrant, third quadrant, fourth quadrant.
First quadrant.
First quadrant it will come? Yes, we will see it. So this is sigma j omega 0 degree, minus 90 degree, minus 180, minus 270. And you can observe here, there are three poles lying at the origin. 9 into 3, 270 degree. 270 degree clockwise. 270 degree clockwise. So I will shift the starting point here. Starting point was here. So 90, 180, 270. Starting point will come here. So for omega equal to 0, starting point has shifted here. Because omega equal to 0, starting point was here for 1 plus ts. Since there are three poles, 90 into 3, 270 degree. The starting point will shift here, 90 degree, 180 degree, 270. And ending point, rotation of the plot remains the same. Rotation means 90 degree clockwise rotation, this one. So 90 degree clockwise rotation remains the same. This we call it as rotation of plot from starting point to terminating point, omega equal to infinity, clockwise. Yes, the plot, your friend has told, the plot will come in first quadrant. It is correct, right? I hope you are getting in the same fashion. I hope you are getting right. Okay. If it is s power 4, once again it repeats. It will come here only. Right? 9 4 is 36. 90, 180, 270 and 360 means once again it will come here only. The same plot repeats, s power 4, right? I hope you came to know the polar plot for simple pole. If I add the pole at origin, how the plot will shift. Only the starting point gets shifted in the clockwise direction by 90 degree based on the number of poles at origin. If there is only one pole, it will shift by 90 degree. If there are two poles, 180 degree, 90, 90 in clockwise. If there are three poles, 270. I hope you are getting right. So this is the summary. Okay, good that you have told, right? I hope everybody has understood. Next, we will see another one. So we have seen 1 plus ts. This is simple pole. If I add one more simple pole for this 1 plus, and this is, let me call it as t1s and 1 plus t2s. If I add one more simple pole, what will happen? Instead of adding pole at origin, let me add one more simple pole. What will happen? We will see. If I add third simple pole, t3s, this is t2s. And what will happen? We will see for this simple pole, right? So let me scratch it. We will continue. Okay, what is the effect? We'll see. Let us add a simple pole and see its effect on the polar plot, right? Okay, g of s into h of s is given 1 divided by 1 plus t1s s1 more. This simple pole we know already. So I will add one more simple pole 1 plus t2s, obtain the polar plot. What will happen, right? So if this is not there, let me assume 1 plus t2s is not there, means the plot will come like this one 1 plus ts. The plot, this is the nature of the polar plot. But if I add one more simple pole, what will happen? We will see, right? Effect of that. Okay, as usual, replace s by j omega. S we are replace 1 by 1 plus t1 j omega, 1 plus t2 j omega. Then get the magnitude. Magnitude, this is the magnitude m. M is equal to magnitude of j omega and h of j omega is equal to 1 by under root, right? Under root of 1 square plus omega square t1 square, right? Then under root of 1 square plus omega square t2 square. This is magnitude m, right? Then calculate the phase phi. Phi is equal to angle of g of j omega and h of j omega. The numerator, angle of 1 is 0 degree. So this is 0 degree, right? So angle of 1 is, this is 0 degree. This one contributes 0 degree. Then angle of this means tan inverse of imaginary part by real part. Tan inverse of omega t1 by 1. So tan inverse of omega t1 by 1. So tan inverse of omega t2 by 1. Take this to numerator, 0 degree. This is 0 degree minus tan inverse of omega t1 minus tan inverse of omega t2. This is phase phi. So and this is the magnitude equation. Yes, we have magnitude and phase. Just we'll take the starting frequency and terminating frequency. We'll call it a starting point and terminating point. So starting point omega equal to 0. Don't take omega tends to omega equal to 0 only. And terminating point omega equal to infinity only. Right? So first let us calculate the magnitude and phase for omega equal to 0. This is magnitude and angle phase. Let me write it. So omega equal to 0. Substitute omega equal to 0 in magnitude. This is 0. So 1 plus 0, root 1 is 1 into this is 0. So root 1 into 1, 1 by 1. So magnitude is 1. Yes, this is fine. Then what about the angle? Substitute omega equal to 0. Tan inverse of 0 is 0. Tan inverse of 0. So 0 degree. So this is also fine. 1 at an angle of 0 degree. Magnitude at an angle of phase phi. So for omega equal to infinity, calculate magnitude. So substitute infinity here. Anything divided by infinity will be 0. So magnitude is 0. Next substitute omega equal to infinity in phase equation. So tan inverse of infinity is 90 degree. Minus 90 minus 90 minus 180. Right? This is minus 90 minus of 90. So minus 180 degree. I hope if any doubts, please ask how to calculate magnitude and phase. I am assuming that yes, you are familiar, you are comfortable in calculating the magnitude and phase. I am going fast, that's all. If you ask, I'll stop and tell once again. Right? Next, we have the magnitude and phase values for starting point of frequency and terminating point of frequency. Then what is the rotation of the plot? So we will calculate the rotation of the plot. Right? Rotation of the plot is equal to, you subtract like this. Terminating point phase angle, this is phi 1 phi 2, phi 2 minus phi 1. So minus 180 degree minus 0. So minus 180 degree minus 0. So I am getting minus 180 degree. Since the angle is negative, so the plot has to rotate by 180 degree. In which direction? Negative means clockwise. 180 degree clockwise. Suppose this is plus 180. The plot has to rotate by 180 degree anti-clockwise. Anti-clockwise is positive, clockwise is negative. So since I am getting negative, so you can write simply clockwise, or else if you want to be very clear, the plot, the polar plot, let me write polar plot. The polar plot has to rotate by 180 degree in clockwise direction. If you want to write it like this. This will be very clear. Okay, with all this information, we will try to draw the polar plot. If I go to the next slide, I have the solution. Okay, let me go to the next slide. Yes, I'll show you. I'll tell you. Omega equal to 0. So magnitude is 1 at an angle 0. So angle is 0. 0 degree means, so this is 0 degree. Minus 90. Minus 180. This is minus 270. So this is real axis sigma and this is imaginary axis j omega. Right? So for omega equal to 0, angle is 0 degree, magnitude is 1. Angle is 0 degree means this line, magnitude is 1. From here to here, magnitude is 1. So this is for omega equal to 0. This is for omega equal to 0, starting point. Right, this one. We have marked here. Next, terminating point. For omega equal to infinity, angle is minus 180, magnitude is 0. So minus 180 is this line. Right? So magnitude is 0. Mark this. This is for omega equal to infinity. Don't take tends to omega equal to infinity. So this is terminating point. This is starting point. Then what is rotation of plot? The plot has to rotate by 180 degree in clockwise direction. Observe here. So if it comes and rotate and join like this, it is 90 degree rotation. If it joins here only. But 180 means it has to cross this 90 degree line. So from here to here 90 degree, another 90 degree, and you join it here like this, right? I hope you are getting, right? So 90 degree here, till here it is 90, another 90. It is totally 180 degree clockwise because the polar plot has to rotate by 180 degree clockwise direction. This is in the clockwise direction only, right? This is clockwise direction. So this is the polar plot. So you show the arrow mark. So 90 degree plus 90 degree, totally 180 degree clockwise rotation. So 180 degree clockwise. rotation. This is the polar plot. POLAR. I hope you are getting. So once again, we will make some observation. Just if I add one of the pole at origin, two poles at origin, here if I add one of the simple pole, if I add two simple poles, what will happen? Just conclusion will make. It can be concluded that a simple pole keeps the starting point of the starting point same. Starting point means this one, it is same. See here, if I take 1 by ts, you can see here 1 by ts, the starting point is here only, right? On the real axis, 0 degree. If I add one more simple pole, the starting point is still on 0 degree. Starting point is not going to change, right? So it can be concluded that a simple pole keeps the starting point same. This is very important, but adds 90-degree clockwise rotation to the polar plot. Adds 90-degree clockwise rotation means earlier there was, due to this 1 plus ts, 90-degree clockwise already it is there. If I add one more simple pole, 90-degree plus 90-degree, 180-degree. So it is from here to here it is 90, another 90, 180-degree. Okay. For this, can anyone draw? You draw it. You try to draw the polar plot for this. Don't calculate magnitude, phase, everything. Directly you have to draw. Just by observation. You read this point once again. You read this point. It can be concluded that a simple pole keeps the starting point same, but adds 90-degree clockwise rotation to the polar plot based on the number of simple poles. So you try to draw it, and I'll give some time and tell me whether you are drawn correct or not. 0 degree, minus 90 degree, minus 180, minus 270 degree. So this is real axis sigma and imaginary axis is j omega. Okay. For 1 by 1 plus ts, starting point is here. Starting point does not going to change. This is same for omega equal to 0. If I am adding two simple poles, for 90-degree contribution is by this 90, 90, 90, 90 by this, 90 by this, 90 by this. So 270-degree clockwise rotation, 270-degree. So if I come here 90-degree, if I come here 90, 180. So I'll join it like this. I hope you are getting. So I observe this is the polar plot. So here omega equal to infinity at this point. So this is the rotation of the plot. So 270-degree clockwise rotation, 270-degree clockwise rotation, clockwise rotation. How it is 270-degree? I'll tell you. Observe here. From here to here it is 90-degree. From here to here it is 90-degree. From here to here it is 90-degree. So 90, 90, 90. Total it is 270-degree. So this is the polar plot. Is it fine? Anybody has drawn correctly? Can you respond? Anybody has drawn the polar plot correctly for this?
Yes, sir.
Yes, good. Who is that?
Yes, sir.
Please tell your
Vinayak.
names. Vinayak. Yes, good. Madam, one more.
Deepa, sir.
Deepa. Deepa Nyamti. Good. Very good. Next, anybody? Please tell your names. I'll be very happy. Okay, fine. I hope you got it. Yes.
Yes, sir.
Good. See, if I add, okay, I'll summarize the thing, whatever we have studied. I'll summarize. Okay, I want one more slide, but I don't have any other slide. Just let me take it here. Suppose g of s into h of s is equal to 1 by 1 plus ts, right? If I add, means I can add, go on adding g of s into h of s, what we have studied, just I am summarizing it. I will add one pole at the origin, 1 plus ts. So I know the nature of polar plot for this, but no need to get the polar because I know the nature, how it is. For g of s into h of s is equal to 1 by s square. I am adding two poles at origin, 1 plus ts. Next, g of s into h of s is equal to 3 poles at origin, s cube into 1 plus ts. This is one type we have studied, right? So if I add one pole at origin, what will happen? The polar plot will, the starting point of a polar plot will shift by 90 degree. If there are two poles, 90 into 2, 180 degree. If there are three poles, 270. It means the starting point goes on shifting by 90 degree based on the number of poles at origin. This is one category we have studied. Next, this is same. I have this one, right? Let me write it here with another ink. Okay, g of s into h of s is equal to 1 divided by 1 plus ts. This is the simple pole, same as this, right? Same as this. I have this. Then I will add go on adding simple pole for it. G of s into h of s is equal to 1 by 1 plus t1s into, I will add one more simple pole, 1 plus t2s. I know the nature of this polar plot, so I can predict, because what will happen if I add one more simple pole, the plot already 90-degree by this, so one more simple pole means there are two simple poles, means 180-degree clockwise rotation for this. Next, this one, third one, it is already here, so let me write it here so that for continuation, 1 divided by 1 plus t1s, sorry, into 1 plus t2s into 1 plus t3s. Similarly, it continues and so on. So 90, 90, 90, 270 degrees here. The starting point remains the same, 90 degree, 90 degree, 270 degree. I hope you are getting whatever I told. So you can draw the polar plot if there are poles added at the origin. If there are simple poles added, you know how to draw the polar plot. You came to know, right? Next. Still time is there. It's already okay. Another 3 minutes is left, so I'll stop here only.